Dry-type transformers can be rated as open-air or fan-assisted. The open-air rating refers to the capacity of the transformer when operating in an ambient temperature of 40 degrees Celsius without fans. The fan-assisted rating refers to the capacity of the transformer when operating in an ambient temperature of 40 degrees Celsius with fans. The difference between the open-air and fan-assisted ratings is typically 33.3%, meaning the fan-assisted rating is 1.5 times the open-air rating. Transformers can also be rated open-air or fan-assisted with a 55/65 degrees Celsius rating. The 55/65 degrees Celsius ratings refer to the temperature rises of the transformer when operating at the open-air or fan-assisted capacities. The 55 degrees Celsius rating refers to a 55 degrees Celsius temperature rise above the ambient temperature of 40 degrees Celsius. The 65 degrees Celsius rating refers to a 65 degrees Celsius temperature rise above the ambient temperature of 40 degrees Celsius. For example, a transformer with an open-air/fan-assisted/55 rating refers to a transformer with an open-air capacity of 100 kVA, a fan-assisted capacity of 150 kVA, and a temperature rise of 55 degrees Celsius at both open-air and fan-assisted capacities. A transformer with an open-air/fan-assisted/65 rating refers to a transformer with an open-air capacity of 100 kVA, a fan-assisted capacity of 150 kVA, and a temperature rise of 65 degrees Celsius at both open-air and fan-assisted capacities. For liquid-type transformers, the increase in capacity with fans is typically less than 33%, usually around 20 to 25%. The different ratings available for liquid-type transformers with fan ratings and temperature ratings include open-air fan-assisted, open-air/fan-assisted, open-air/fan-assisted/55/65 degrees Celsius, and open-air/fan-assisted/65/80 degrees Celsius. The actual capacity increase and available ratings may vary depending on the manufacturer and specific transformer model. It is recommended to consult the manufacturer's specifications for specific information. The ratings are open-air fan-assisted, open-air/fan-assisted, open-air/fan-assisted/55/65 degrees Celsius, and open-air/fan-assisted/65/80 degrees Celsius provide information about the transformer's capacity and temperature rise under different operating conditions. Firstly, open-air refers to the transformer's ability to operate at its rated capacity without any forced cooling, relying solely on natural convection and radiation to dissipate heat. This is the base rating of the transformer. Secondly, fan-assisted indicates that the transformer is equipped with fans to provide forced air cooling, which increases its capacity beyond the open-air rating. The fans help to remove heat more efficiently, allowing the transformer to handle higher loads. Thirdly, open-air/fan-assisted represents a transformer that can operate in both open-air and fan-assisted modes. It has a base rating for open-air operation and a higher rating when the fans are activated. Fourthly, open-air/fan-assisted/55/65 degrees Celsius indicates that the transformer has a dual temperature rating. The 55 degrees Celsius rating represents the maximum allowable temperature rise above the ambient temperature when operating at the open-air capacity. The 65 degrees Celsius rating represents the maximum allowable temperature rise when operating at the fan-assisted capacity. Fifthly, open-air/fan-assisted/65/80 degrees Celsius is similar to the previous rating, but with higher temperature limit. The 65 degrees Celsius rating is for open-air operation, and the 80 degrees Celsius rating is for fan-assisted operation. It's crucial to understand that these ratings are provided by the manufacturer and are specific to the transformer model. The actual capacity increase achieved by using fans depends on the transformer design, the ambient temperature, and the efficiency of the cooling system. For example, a transformer with a rating of 100 kVA open-air and 133 kVA fan-assisted has a 33% increase in capacity with fan cooling. This means that with the fans operating, the transformer can handle 133 kVA of load without exceeding its temperature limits. However, If the ambient temperature is higher than the specified design temperature, the transformer's capacity may need to be derated to prevent overheating. The temperature ratings also play a vital role in determining the transformer's lifespan and reliability. Operating a transformer above its temperature limits can significantly reduce its installation life and lead to premature failure. The 55 degrees Celsius and 65 degrees Celsius temperature rise limits are based on the insulation class of the transformer. Higher temperature ratings are possible with improved insulation materials. It's important to note that temperature rise is the difference between the transformer's winding temperature and the ambient temperature. The winding temperature is the hottest part of the transformer and is difficult to measure directly. Instead, the temperature rise is typically measured using thermocouples or resistance temperature detectors attached to the transformer's core or windings. The manufacturer provides guidelines for interpreting the temperature measurements and ensuring that the transformer is operating within its specified limits. In summary, the open-air, fan-assisted, and temperature ratings of a transformer provide essential information about its capacity and thermal performance. These ratings should be carefully considered when selecting a transformer for a specific application. Consulting the manufacturer's specifications and adhering to the recommended operating conditions will ensure the transformer's safe and reliable operation. Furthermore, the selection of a dry-type versus a liquid-type transformer depends on several factors, including the application requirements, environmental conditions, and cost considerations. Dry-type transformers are generally preferred for indoor applications where safety and environmental concerns are paramount. They eliminate the risk of oil leaks and are less susceptible to fire hazards. However, dry-type transformers typically have lower overload capacity and higher operating temperatures than liquid-type transformers. Liquid-type transformers, on the other hand, are more suitable for outdoor applications or where higher overload capacity is required. The oil used in liquid-type transformers provides excellent insulation and cooling properties. However, liquid-type transformers require additional maintenance and are subject to stricter environmental regulations. The choice between dry-type and liquid-type transformers should be based on a thorough evaluation of the application requirements and a careful consideration of the advantages and disadvantages of each type. Understanding the open-air, fan-assisted, and temperature ratings of a transformer is crucial for ensuring its safe and reliable operation. By carefully considering these ratings and consulting the manufacturer's specifications, you can select the right transformer for your specific application. Additionally, it's important to consider the installation environment and ensure proper ventilation to prevent overheating. Regular maintenance, including inspections and cleaning, is also essential for maintaining the transformer's performance and extending its lifespan. In conclusion, the transformer ratings discussed provide valuable information for selecting and operating transformers. These ratings are essential for ensuring the safe and reliable operation of electrical systems. Remember that the specific capacity increase with fan cooling depends on the manufacturer's design. Always consult the manufacturer's specifications for detailed information.